True or false? Curve duration is a type of yield duration-based measures in a future reading. Kind of out of place here. It is not a type of yield duration. That is false. Okay, next three questions require you to do some spreadsheet calculating. Pretty straightforward. Portfolio manager is assessing the interest rate risk of 3 bonds as she considers making an investment of $50 million. All 3 bonds are issued on June 1st, 2026, mature on June 30th, 2030, and have the following characteristics. Coupon semi-annual. They're all 4-year semis. Notice bond 1, yield to maturity is 3%, coupon of 7. We are dealing with a premium bond. Bond 2, coupon of 3, yield to maturity of 7. We're dealing with a discount bond. And bond 3 is a par bond. And we are asked to calculate the Macaulay duration for bond 1. Our first column is time to receipt. Since we have 4-year semi, we're going to have 8 cash flows. Here's our cash flow, 7% coupon. And of course, we get our par back in the future. Then we have to calculate our present value. In case you're wondering how we get to the present value, we need to know the price of the bond and calculate the interest rate or the market discount factor. So the price of the bond is 114.9714, future value 100, n equals 8, payment of 3.5. You get to 1.5, which is half of the 3% here. So because it's semi-annual, you use the 1.5. So to calculate the 3.44828, we'll take 3.5, discount it at 1.015. There you go. To get the 3.397, you will take the 3.5 discounted by 1.015 squared. And then this is cubed to the power 4, 5, 6, 7, and 8. There's your present value. To get to our weighting, it's up here. It is the present value of this cash flow divided by the sum of all the present values. Your weighting should add up to 1. Then you'll take your time to receipt multiplied by your weighting to get this column. Add up this column. Here you go. That is in semi-annual period, so you divide by 2 to get to 3.59229. That is B. You are given the yield to maturity in the question. Most often you don't have the yield to maturity, but you can observe the price so that you calculate the bond's internal rate of return, its cash flow yield based on the cash flows that are given, because you will have the price that you put out on day 1, and then you use that to calculate your present values. Next question, the modified duration for bond 2 is closest to. So here you have to calculate Macaulay duration again, annualize the Macaulay duration statistic, and divide it by 1 plus R. We know our yield to maturity is 7%. And again, normally you're not given the yield to maturity. When you look in the marketplace, you can observe a price, and you would have to determine what the yield to maturity is. So I give you those steps here. We've already seen how we get the present value. We take the payment divided by 1 plus the cash flow yield, which is 7.5, semi-annually 3.5. There you go. So you should be comfortable now at getting to Macaulay duration. You should recognize that for a semi-annual bond, that's the number of 6-month periods. If you divide by 2, that's the number of years. We want modified duration. It's Macaulay duration divided by 1 plus the periodic cash flow yield, 0.035. 1 divided by 0.035, you get 3.65219. It's B. Okay, this question is asking us a relative question here. Relative to a 5-year zero coupon bond priced to yield 5%, bond 3 has a modified duration that is best described as. I got a little bit of a problem with this question. Okay, we have a zero coupon bond priced to yield 5%. All the bonds we are looking at, bond 1, bond 2, bond 3, the coupon is semi-annual. Are we going to compare it to a 5-year zero coupon bond with an annual yield of 5%? A semi-annual yield of 5%? It's not clear. Let's just assume it's annual. We'll give it the worst possible. For the comparison, we'll put it at the worst possible spectrum, which is making it annual. 5 divided by 1.05, there's its modified duration. If we assume semi-annual would be divided by 1.025, it would be higher. So let's make this the lowest it possibly can be as far as a comparison is concerned. Bond 3 is 4 years and it's semi-annual, which means based on yielding 5%, we will take whatever Macaulay duration we come up with and we're going to discount 1.025. And because it is semi-annual, it is not the same as the annual. So let's see what we get. We can use a bit of logic here to get this done. Even though we don't have exact comparability, we can still use some logic. If we think about a Macaulay duration versus time to maturity, we know a zero coupon bond has a 45-degree angle from the origin. A perpetuity, this is the perpetuity here, is a straight line. We know that a premium bond will always be below the perpetuity in terms of Macaulay duration. The discount bond can climb a little higher than the perpetuity, but we have a par bond. So there it is in blue. It'll be more than the premium bond, less than the discount bond. There's 4 years. So we can just look at its Macaulay duration and say, well, it appears that obviously the Macaulay duration of the 4-year will be lower than the Macaulay duration of the 5-year, but we're going to discount the 5-year at 1.05 and the 4-year at 1.025. Will that make a difference? If we calculate for bond 3 the Macaulay duration and then annualize it, divide by 1.025, we get 3.581, which is lower than 4.761. It would take a much wider dispersion between the discount rate of 5% versus 2.05 to make up for the fact that the Macaulay duration of bond 3 is going to be significantly less than the Macaulay duration of the zero coupon bond. So if you went ahead and just used logic and took a guess saying, well, bond 3 is going to be lower, you would have ended up being correct. If the yields to maturity for all 3 bonds were to increase 100 basis points, which bond has the greatest anticipated decrease in price? It'll be the one with the greatest sensitivity. We know that modified duration is the percentage change in the full price of the bond. So let's find the one with the highest modified duration. That is bond 2. Which bond has the highest price value of a basis point? So we know what we have to do here. We have to increase. For each one, we have a yield to maturity. We'll increase it to 3.01 and decrease it to 2.99. This one, same thing, 7.01, 6.99. And here we have 5.01 and 4.99 and reprice that bond. So bond 1, we know the price was 114.972. If we increase by 1 basis point, we get to 114.931. Decrease, we get to 115. Take the difference between these, divide by 2, you get 0.04069. Do the same for bond 2, the same for bond 3, 0.04069 for bond 1. The portfolio manager is interested in comparing the interest rate risk of bond 3, that's our par bond here, to that of bond 4, a floating rate note that resets every 6 months. On June 1st, 2026, both bonds were priced to yield 5%, so both were at par. If the yield changes from 5 to 5.25 halfway through the first coupon period, which bond has the greater Macaulay duration? Well, we know that a floating rate bond has a maximum Macaulay duration about midway through a reset period, whereas bond 3 is a 4-year bond. It's going to have a significantly higher Macaulay duration. This one is easy to answer. Which bond has a greater Macaulay duration? Bond 3.